everyone. This is Joy from Rawsun Technology. Today I want to talk about something very practical. EV power, voltage, and real-world limits. Because in many projects, the biggest problem is not the hardware, it's misunderstanding. Let's start with a very common situation. Many people want high power, low voltage, high torque, high speed, and low cost. But actually, it's not difficult. It's impossible. Because the limitation is the motor. It's not the motor, it's the voltage. With a 144 volt system, you will have about 15 to 25 kilowatt rated motor and up to 75 kilowatt peak. So the problem is not the bad design, it's too much to expect. So what are the motor parameters? They define performance, they affect efficiency, and they determine the flexibility. So you are not choosing a motor, you are defining a system. Now let's move the key parameters. Rated power, it's what your vehicle can sustain. Peak power, it defines how fast you can accelerate. The torque, it defines how strong your vehicle feels. Speed, and it will let you know how fast your system can run. The voltage, this defines what even possible. And the current, it will define how hard your system has to work. And remember, all parameters are connected, not independent. So why voltage matters? The power is limited by the voltage. And you can see the most important relationship. Power is about voltage times current. This is electrical power. Electrical power must match mechanical output. So lower voltage, higher current. Higher voltage, lower current. So if you try to get high power at low voltage, current becomes very high, and that creates stress, and stress becomes heat. So what is the hidden cause of the high current? You can see it will bring the thicker cables, more weight, more heat, and higher risk. Low voltage systems don't fail immediately. They fail gradually. This is not about good or bad. It's about trade-off. You are not saving the cost. You are moving the cost to risk. So you can see same motor will have different voltage, and then it will have different results. That's why system design matters. What goes in electrically must come out mechanically. So what physics allowed? Now another key rule. Power equals torque times speed divided by 9550. So if you want the high torque and high speed, you must pay with the power. Let's look at an example. 200 kilowatt, 500 Newton meter, and 50,000 RPM. This actually requires about 785 kilowatt. So you can have everything at the same time. And remember, there is no free performance in physics. So smart engineering will use gearing. We don't fight the physics, we work with it. We use a gearbox, reduce speed and increase torque. This is how real systems are designed. So what you should remember? Let's keep it simple. Voltage defines possibility. Power requires balance, and wrong acceptance leads to failure. So when you are designing the EV system, start with the right system, not with the assumptions. And if needs, please contact me. Thank you for your listening. See you next time.